Let's talk about the invisible magic that makes our modern world tick. We're going to pull back the curtain on the secret senses of our technology.
Think about it. You flip your phone, and boom, the screen flips right along with you. Or your house gets a little chilly, and the heat just kicks on. How does it know to do that?
Well, the answer is this incredible, kind of invisible world of sensors. These are the tiny little components that act as the vital link between our physical world and the digital one. They literally give our devices the ability to perceive what's happening around them.
But to really get a grip on this world, we have to start with the language, because you'll hear two words thrown around all the time: sensor and transducer. They're related, for sure, but they are not the same thing. So let's get the terms right.
Okay, so let's break this down. A transducer, that's the broad term. Its job is to convert any one form of energy into another. A sensor, on the other hand, is a specialist. It does a very specific job. It detects a physical thing, like heat or light or pressure, and turns it specifically into an electrical signal that a computer can actually understand and measure.
So here's the golden rule, the one thing you really got to remember. Because every sensor is converting physical energy into electrical energy, every single sensor is technically a type of transducer. But, and this is the key part, since transducers can convert energy in all sorts of other ways that have nothing to do with measurement, not every transducer gets to be called a sensor.
And this just makes it perfectly clear. Over on the left, you've got a thermistor. It senses heat, turns it into an electrical signal for your thermostat. That's a sensor. But on the right, you've got a loudspeaker. It takes electrical energy and turns it into sound energy. See, it's converting energy, so it's a transducer, absolutely. But it's not measuring anything for a computer, so it's not a sensor. Simple as that.
Okay, so now that we know what a sensor is, let's meet the family. And trust me, it is a huge family. Sensors are not a one-size-fits-all kind of thing. They're all specialists, each one designed for a very, very specific job.
So one way we can split them up is based on how they get their power. Active sensors are kind of self-sufficient. They actually generate their own electrical signal when they sense something. A great example is a thermocouple, which cleverly creates its own tiny voltage just from being heated. Passive sensors, though, they need a little help. They need an external power source to work. Think of a resistance temperature detector. Its resistance changes with temperature, but we have to pass a current through it to even see that change. Another way to classify them is by how they talk. An analog sensor gives you a continuous, smooth range of information. It's like a dimmer switch for a light. A light-dependent resistor's resistance changes smoothly as the light gets brighter or dimmer. A digital sensor, on the other hand, is more like a simple light switch. It's either on or it's off, a 1 or a 0. A proximity switch either says, yep, something's here, or nope, nothing. That's it. So where do we find these little specialists? Well, let's start with the ones that sense the world around us. Environmental sensors are everywhere. You've got thermistors acting as the digital thermometer in your HVAC system. You have capacitive sensors that measure the moisture in the air to track humidity. And then you have things like MQ series gas sensors that can literally sniff the air to warn us about dangerous gas leaks. And what about movement? Remember that phone screen we talked about at the very beginning? Well, that's the magic of an accelerometer and a gyroscope working together. They detect motion, orientation, the whole shebang. And every time you step on a digital scale, a tiny sensor inside called a load cell is precisely measuring the force of your weight. These are the sensors that give our tech a sense of physical space. But with all these different types, how do engineers know which one to pick? What separates a really good sensor from a not-so-great one? Well, every sensor basically comes with its own report card, a list of its key characteristics. First up on the report card is range. This one's pretty straightforward. It's just the lowest and highest value the sensor is designed to measure. You wouldn't use a kitchen scale to weigh a truck, right? Same idea. You need the right tool with the right range for the job. Next is sensitivity. This tells you how much the sensor's output changes for a certain change in whatever it's measuring. A more sensitive sensor gives a bigger electrical shout for a smaller physical whisper. In this example, for every single kilogram you add, the electrical signal goes up by a predictable 2 millivolts. Linearity is all about consistency. A perfectly linear sensor is like a perfect volume knob. Every single click up gives you the exact same increase in sound. If the relationship between what it's sensing and the signal it's sending is a nice, straight line, it makes the data incredibly easy and reliable to work with. Response time is absolutely crucial when speed matters. It's how quickly the sensor can report a change. A thermocouple can spot a temperature spike in milliseconds, which is vital for safety systems. An old mercury thermometer might take a full minute. fine for checking the weather, but not for a high-speed industrial process.
And then you see a number like this, plus or minus 0.5%. What does that even mean? Well, this is the big one, accuracy. This is how close the sensor's reading is to the absolute, real, true value. A sensor that's accurate to within 0.5% across a 100-degree range will be right to within 0.5 degree. For science and medicine, that kind of precision is everything.
Okay, so we've defined them, we've met the different types, we've even graded their performance. Let's zoom out now and connect all this back to the world we actually live in. What's the big picture here?
Just look around. The technology that really defines our lives is built on a foundation of sensors. Your smartphone is jam-packed with them. Your car is using them constantly to monitor everything from tire pressure to how the engine is running. Drones, life-saving medical gear, the smart home that keeps you warm in the winter, all of it depends on these tiny little sensors.
There's this quote that just says it all perfectly. Without sensors, our machines are basically blind, deaf, and dumb. They've got no connection to the real world. Sensors are what give them the ability to perceive, to react, and ultimately to help us out.
So if you remember one thing from all of this, let it be this. Sensors are the translators. They take the language of the physical world, heat, light, motion, pressure, and they convert it into the language of bits and bytes that our computers can speak. They are the bridge that unlocks pretty much all the incredible stuff we now just take for granted. Which kind of leaves us with one last big thought. We've managed to give our technology this amazing array of senses, letting it understand the world in ways we couldn't have even imagined a few decades ago. So the question now is, what's next? What new senses are we going to invent? And what incredible new worlds will that open up for us?